All right. Now that you know how a data or stack data structure works in general, now let us just try to implement it in this main.c file we already have over here. Okay. Now I'll just leave that import over there because I don't want to screw up this thing. Okay. So let us have a global variable, a global array called stack. And initially, let us assume we have 5 elements in that. And since we, as already discussed, we'll have to have a pointer called, or running pointer called top, whose initial value will be -1, because if it is 0, that means the topmost element is at the 0th position. That means there is one element in the data structure, but that is not true because initially there will be 0 elements, and hence we'll have 1 minus the minimum number of elements that can be present in a stack, and hence it will be -1. Okay. Now, first things first, we'll write some utility functions first, which is isEmpty over here, because isEmpty function, it just does nothing, but it tells us that if the data structure is empty or not. Okay. Now, this is possible to check if the initial conditions are met, right? The top variable, whenever we are pushing an element in the stack, we'll be incrementing it, and whenever we are popping out from the stack, we'll be decrementing it. Hence, the only position when the stack is empty is -1. So if you check a Boolean value, this decomposes into a Boolean. If this is equal, it turns into a true or it into a false. And hence isEmpty returns a true or false, a 0 or 1 basically. That we don't have Booleans in C, that is how we use ints over here. Okay. Now we also have another function called isFull. Now what isFull does is, it'll take, since we have 5 elements in the stack, which is the maximum size that can be fit into that stack. If the top variable is 4, that means 0 to 4, 5 elements are already filled, right? Because 1 minus the maximum length of the stack will be, the maximum capacity is already completed and we can't push any more elements or stuff like that. So we check if the stack is full by checking if the top variable is equals to 4, because 4 and not 5, because top deals with indexes and not the number of elements. Okay. The number of elements will be always 1 greater than the index of that element. Now we have an issue here because you just can't hard code your values like 5 and 4 over here. Okay. So we can use a constant variable or a global variable and int max size equals to 5. And we can use that max size over here and over here, -1 and everything. But it's not a good practice and it is not advised to do so. Instead, what we can do is write a macro. Okay. We'll be writing max size macro over here. I hope you know what macros are. After macros, we can't put a semicolon. We are defining a new macro called max size and its value is 5. Okay. Now, instead of hard coding 5 over there, I can have the macro over here. Similarly, I can have the macro over here. And since that is equals to 5 and we need 1 less than that, we'll be doing this. Now, whenever you want to change the maximum capacity of your stack, we'll come here, we'll put it to 10 if you want to. And the isFull will be top equals to 9. And yeah, the stack will be initiated with 10 elements of capacity, 10 integer values, 10 into 4, 40 bytes of memory will be allocated for this. Now whatever we're doing over here are global variables, and we are just using the stack memory over here, not the heap memory. Heap memory deals with pointers and references and all of that stuff. Stack memory is pretty fast because we just ends in the execution context of this main function or whatever function they are declared inside. Yeah, and they're always copied by value and not by reference because they are created in the stack. Okay. I hope you have basic knowledge of C programming. Now let us get into the most important function of a stack, which is to push an element. To push an element, we'll need a parameter, and let us name it as element. We should be very pessimistic when it comes to coding data structures. All right. The first thing that should come into your mind is, what if the push element can't be possible? And when it won't be possible is when the stack is already full. So we'll have to first check if the stack is already full. All right. So we check if the stack is full and we return a 0, showing that it's false, that yeah, the push operation has not been completed, and hence I'm returning a falsy value over here, which is 0. Okay. Now, what if it is being completed? Now we'll have to assume that the stack is empty. And if it is empty, it is at -1, and we want to put the first element at the 0th position. So to put the first element at the 0th position, you should have the top variable incremented first, and that's what we do. We just do plus top or top plus plus, postfix or prefix, your wish, but I'll discuss the differences between them. And yeah, we have the stack global variable, and now top value is 0, and we just put our value element over there. Okay. And since the pushing of an element is completed successfully, we'll be returning a truthy value, which is 1. And yeah, so if you're returning a 1, that means the element is returned successfully. If you're returning a 0, the element has not been pushed successfully. Okay. Now, we can also add the plus plus top over here because that's a prefix incrementation operation. So first that will be executed and only then stack of the 0 will be pushed into the stack and all. Okay. I'll explain that in the next lesson too. Now, how do you pop out a stack? Okay. Now the pop method, another thing that I want to tell before coming into the pop method or anything, there is no specific way to code a data structure. Okay. There is nothing like a golden book and a democratic constitution written for writing data structures. There are multiple ways of implementing a data structure and it's just your own way and the way you're comfortable with while writing data structures. Okay. So the approach that I take while writing data structures is the pop method. It just pops the topmost element from the stack or whatever data structure we're returning, and it'll return a Boolean value instead of the popped out element. Okay. And the peek method shows the topmost element or the rear element or the front element, whatever. Okay. And we can combine those two methods by returning the topmost value and also deleting it in the fall method. Okay. So I'll be writing 3 methods over here. So just so you know, we have multiple methods and we have so much functionality in here. Again, you should be pessimistic while writing data structures. And when can't we pop out of a stack? We can't pop out of a stack when the stack is already empty. So we check if the stack is already empty over here. And if it is empty, we are going to return 0, right? Now, what if it is not empty? Now, coming to this kind of implementation, since the elements are already created in the stack memory, and they are volatile and they'll be fast, but they'll be volatile. And we can only allocate memory by using this declaration over here, but we can't deallocate memory because it's a stack memory allocation. And hence, since we can't do that, what we'll do is, we know that we'll be displaying the stack only from the 0th position to the top element position, because wherever the top is, that means the final element in the stack is present over there. So though we have the elements present in the stack in the array. For example, let us assume the array is 1, 5, 2, 3, and 4. Though we have, for example, if we have 5 elements, the value of top will be at 4 over here. But while we are popping an element, what we do is we decrement it to over here. That means we are not deallocating this memory over here, but we are decrementing the top variable, because while printing the stack to the console or whatever, we'll be just printing from 0th position to the top element. And we'll be ignoring this, whatever is stored after the top element's index, though it is actually being stored in the data structure. All right. So yeah, that is not a quite good approach, because we are this space of memory, we are wasting it, though we are not using it. You might find it simple and small, but yeah, while you're dealing with a bigger data structures, even a small element matters the most. Okay. So yeah, that hurts, right? Because we can't waste memory just like that. So as of now, what we'll be doing is we'll be decrementing the top variable. Okay. We'll just decrement the top variable and we'll show that, yeah, the pop operation has been completed and I'm returning a truthy value. What if I don't want to delete anything from the stack, but I just want to show or know what is the top element in the stack? Now, this is quite similar to this, because we'll copy that, paste over here. And again, you have to be pessimistic. What if we can't show the top element, and only that will be possible only when we are not having any elements in the stack. And since if it is empty, we can't return 0, because 0 can be the top element in the stack, and you can't just hardcore a value like 0, because you're not returning a truthy or falsy value. You're not returning a Boolean over here, but you're returning the value of the topmost element. So as of now, I'll be having a weird number called -9999. So yeah, that is the number I chose to show that whenever in the main function, while you're implementing the peek function or whatever, if the returned value is -9999, that means the stack is empty. Okay. It's like a communication signal between the peek function and the main function while executing it. Now, what if the stack is not empty? Then we just return the topmost element, just like this. Stack and top is index, and whatever value is present in that array at the top index, we just return it. Okay. Now, I want to combine these both methods. I want to return the topmost element, but I also want to delete it or pop it out of the stack. Now, that method, I call it as pull. All right. Now, I can come over here. I can fall elements. I can check if it is empty. Same thing. Since we are not returning a boolean over here, I'll have to do that peculiar number, whatever it is, and I'll have to return that element that we have. For example, I can have a result variable as of now, because if I just decrement top like this, and before decrementing, I'll have to store the value of top here, because stack of top, now that we are, all right, yeah, this is an integer. All right. So we are creating a variable called result. We are storing the topmost value, which is whatever is the topmost value in the stack. And we are decrementing the top. So we no longer have access to the topmost value, and we are returning that result. Now, this process can be broken down into a single line. Okay. You just don't need to do all that stuff. You can just come over here and put your top variable over here and have a postfix decrementing operator, because since we are doing the postfix decrementing operator, the stack of top will be first returned, and after it is returned, the top variable will be, since it is a postfix, after that it is returned, it will be decremented. Unlike the prefix decremented, where if at all we are doing minus top over here, first it will be decremented, and then the stack of the top will be returned. And that is not what we want, because then it will be returning the new top variable, and we want the old one. Okay, so this is how we can use beauty of postfix and prefix operators in the C programming language. Okay, we have push, pull, peek, and pop. And let's also just write a simple linear search algorithm. And I want to search for an element called key. Okay. Now, again, you got to be pessimistic. I'm just going to do that. I'm going to return a minus double and double n. But what if the stack is not empty and you're having some elements in there? So now we'll write a for loop, and I'll just take int, and that will be I, and here the count will be top, because yeah, 0 to top, that is how we will be traversing. And I'll just do that prefix, because I heard that it is quite quicker when compared to postfix arguments. And also, since top is index and not a number, we'll have to use that less than equals to over there, because the top is 4 and not 5. And if it were 5, you should just use this. Or if you still want to use this, you'll have to append 1 over here. Okay, yeah. So I just like to do this. And what inside the loop? We'll have to check if any of the position of that stack is equals to the value of the key. And if it is equal to the key, I'll return the index, which is I, right? Because the current index is 0 initially. We'll be checking if stack of 0 is equals to key. If not, we'll again come to stack of 1. If it is equal to, we'll return the 1 over here. If it is not, again, we'll come to 2 and all of that. If you want, I'll just debug this code and show you too. Okay, we did not find the loop is completed. We did not satisfy this condition anywhere, and hence we did not return out of this for loop anywhere. Then we just want to return a -1, because remember, we are returning indices over here, and -1 can never be an index for an array, right? So we'll be returning -1, and hence we have to check for the return value of the contains function. If it is equals to minus double and double line, that means we can't check for a key in this array because the stack is empty. If it is -1, we say that there is no such element called key inside the stack. And if a number other than these two is returned, that means at that position in the stack, we have the desired element over there. Okay. Now I'll write a very similar method called print stack, just to print the values of the stack and all. Obviously, we won't be having any parameters over here. And instead of doing this, I'll just write a printf and tell you that the stack is empty. All right. Yes. Obviously, I should have a semicolon. Now, inside the for loop, there is no if checks and there are no return statements. And this is a void return because we don't have any return statements over here. And this should be in an else clause, right? Because until here, in every if condition we are writing, the very next statement is returning statement, and hence even if this if condition is false, we'll come to the for loop directly. We don't need an else condition, all right? But it's not the same case over here. If this if condition is false, this for loop will still run even though the stack is empty, because we are not returning over here. I can just write a return statement over here, but I just don't like, I can have a void thing and do that. Okay, so what for me? In the else clause, wait, I'm pretty confused with this. Yeah, cool. No. That's good. Okay, so I'm just going to printf %t, and I'll just have that \n over there. And I'm going to print that element called stack of I, because I is the current value of the pointer, and that's what we do. Okay, so what we are printing over here is the first element and /n and the second element and till the top. That means till the array is complete. Okay, so that is how we print a stack. This is called traversing through the data structure. We'll start from the starting point and we'll go through the ending point, and we traverse through the data structure. Now let me implement the main function, and let me just add some push functions over here. Okay. Oops. Why am I getting that name wrong? I'll just go through the maximum limit over here. So 5, 1, 4, 2, and 3. Cool. Now I'll just print the stack function like this. Now I'll press Control Shift B. It'll first compile my code, and then it'll run my code, and it's going to show 5, 1, 4, 2, 3. The latest element on the top of the stack is 3, but we are seeing 5 over here because while printing the stack, we are starting from 0. If you don't want that to happen, let me just close this. Right. Just close this, and I'll start from the backwards. I'll start from top. I'll check if the element is greater than or equals to 0, and I'll decrement it from top to 0. Prefix decrementing operator. Now this will be cool. First, I'm going to compile it and then run it. Yeah, you see that? Print stack function is going to execute 3, 2, 4, 1, 5. Okay. Now this code is fine. We did well in this here, but there are some terrible mistakes and terrible coding practices that we have involved over here. First thing, we are using integers as Boolean equivalents over here, 1 as a truthy value and 0 as a falsy value. In fact, we have a standard bool header in C, and we'll be implementing that in the next function. Okay. And we are using global functions, which is AO. Should not use global functions in any programming language. Global functions are really dangerous, and I advise you not to do them. Okay. So also we are having two global functions. Like this is an array, and this is a runner through that array. It's just a pointer pointing to position of the topmost element in that array. So these are associated, right? These are related to each other. Now, when two things are related to each other, it's always a good practice to have them in a class. And now that we don't have classes in C, we do that using structures. And even while using structures, we can also reduce the amount of code we write by using type defs and macros and everything. We'll have to keep updating this max size thing over here to 6 when we want, or 10 when we want, because we'll have to make a change in the line of code if we want to have dynamic input and dynamic memory allocation. And instead of creating stack-based memory, we can use heaps, and we can use the malloc function, the standard library functions, and we can use just the one element created over there, and we can just play catches with it through the functions and all. Okay. And also this is not at all a useful macro, and we are returning some arbitrary value called -"n". It's always a good practice to have that as a macro, and even at times you can have -"n" as an array index in your stack. So we'll figure out what is a good number to have that as a stack empty value and all. Okay. So we'll be refactoring this code into better coding approaches and better coding practices in the next video. And then that is the pattern that we'll be following. That is the same pattern that we'll be following for the remaining data structures. So I'm showing you this because this kind of code is beginner friendly, and I just want people to understand the logic behind stack and everything. Now that you get the point, I'll be rewriting the stack data structure again in the next video.